So, hey guys, I'm Fibs, and today we're going to talk about fuzzballs and electrostatics. So, a little bit of disclaimer. In this video, I'm going to talk about the basic concepts. So, if you already know the concepts, you think you're good to go, then you can totally skip this video and go right ahead to the problem solving. Care of Anne and Mika and Gerald. So, anyway, first off, let's talk about electrostatics. Electrostatic is the study of is a science or the study of all phenomenon related to charges at rest. So basically, objects have charge. If you saw the triboelectric series, particularly everything has charge. My skin has a charge. These pajamas have charge. This piece of paper has a charge. Well, everything has a charge, whether it's positive or negative. If an object or a perfectly neutral thing loses an electron, it becomes positively charged. If a thing gains electrons, it becomes negatively charged. But this charges or something that is charged or being charged is not about positivity or negativity alone. Being charged or charges refers to how positive and how negative an object is. So that means we're going to talk about numbers. So maybe we could say nga, mas simple ra siya if moingon ta nga, oh, this object, this swan right here, this fuzzball swan, is has a charge of 5 protons. I mean, we already have protons and electrons, diba? So why is it sa book there's this thing called coulombs, which is also referring to charges? What okay, we already know protons and electrons, positive and negative. What's the point of all the coulombs? But trust me, it's very, very convenient. Because first off, we know how small an atom is, right? Like it's so small we can't even see it. So for a mere object like this, we know that there's a million or even more atoms in just this small thing. And if daghan kayo siyang atoms, what more electrons and protons, diba? When those things are much more smaller. So this thing has a lot of protons and electrons. So if we say that this has a charge of 1 coulombs, we just don't say na naani siya 1 proton greater than an electron. No, because 1 coulomb is not equivalent to 1 proton. Let me explain why. According to the book, according to the book, 1 coulomb is equivalent to 6.24 times 10 to the 18. Okay, we see it as numbers, but let me give meaning to these numbers. 6.24 times 10 to the 18 E. Now, what is E? Okay, E is an elementary charge, aka E is the charge that every single proton have. So basically, we can say that 1 proton has 1 E. And because of that, 1 coulomb is equivalent to 6.24 times 10 to the 18 protons or electrons. What does that mean is this. 1 coulomb, 1 positive coulomb, or positive 1 coulomb is equivalent to 6 quintillion protons. Now, dude, that's a lot of protons. What again? Okay, this simple number over here actually mean all of these. So what makes up that positive charge is not just 1 proton, but 6 quintillion of protons. That's why, it'd be so hard to say na this fuzzball swan is positively charged by 6 quintillion of protons, or is negatively charged by 6 quintillion of electrons. Now that's a lot of math and numbers and zeros. So would it be more easy, diba? Na atong i-say kay this is charge, or this has a charge of 1 coulomb. Okay. But there's just another number that comes in the book. Diba we have this. 1 coulomb is equivalent to 6 quintillion. Oh, an extra. 1 coulomb is equivalent to 6 quintillion of protons. But the question is, for every single proton or electron, pila ang charge niya in coulombs? So like, how much coulombs are there in a single particle? The answer to that question is, we divide 1 by all of this. So bali 1 coulomb divided by 6 quintillion. And then, if you do that, you get an answer of 1 elementary charge is equivalent to 1.602 times 10 to the negative 19. Which means to say, every single particle has a charge of 1602. Every single particle has a charge of that. This one refers to positive 1.602, so protons. But if it's an electron, this becomes negative 1.602. So, ta-da! Anyway, all of that refers to the basics. At least, a bigger view of things and understanding. So next, okay, so now, let's talk about the conversation of charges, or like, so the conservation of charges. So basically, by the conservation rule, charges are neither created nor destroyed. So if this Mr. Penguin right here suddenly gains a charge, that doesn't mean that the charge was created and given. That could basically mean, or it could has a possibility of meaning, that that charge that Penguin gained actually came from Blue Narwhal. So there is no creation nor destruction, but a transfer of charges. Now for charged particles, they have the tendency to equal out if their size is the same. So let's say, for example, that Swan here has a charge of 3, and this guy right here has a charge of 1. So once they come into contact, there is a transfer of electrons. Remember how this one is 3 and this one is 1. So before the reaction, or before the contact, there is a total charge of positive 4. But after the contact, this guy lost 1 coulombs, so it only has 2 coulombs left. Now this guy gained 1 coulomb, so it has 2 coulombs now. But if you add that together, 2 and 2, it's still 4. So according to the conservation of charges, the charge, or the total charge before the contact, is the same as there was after the contact. So remember how before there's 3 and 1 is equivalent to 4, and then after 2 plus 2, which is also equivalent to 4. Now, that's in the case of if they have the same size, they tend to equal out. Now, once we have a difference in size, wherein one is bigger and one is smaller, they tend to distribute their charges according to their radius, or radii. So, the concept behind this is that the bigger something is, the more charges they tend to have, or they tend to get. So, say for example, I'm sorry, I'm sick. So say for example, this one has a radius of 1, and this penguin has a radius of 2. So you can see how there is a 1:2 ratio between them. So let's just say that this one has a charge of 0 and this penguin has a charge of 3. So if they come into contact, we can't say 1.5 transfers to this guy because that would be half. But instead, only 1 coulomb of charge transfers to this guy and 2 coulombs remain in the penguin. Because, again, 1 radius, 2 radius, 1 charge, 2 charge. So you see the pattern. But let's say that this guy still has 0 charge and this guy has a charge of 6 coulombs. Once they come into contact, they follow the 1:2 ratio. So 2 coulombs are gained and here 4 coulombs remain. But if you add that, like before the contact there's 0 plus 6 and then after the contact that's 2 plus 4. So it's still 6. Now the conservation rule is still being followed. Ta-ta. Okay, so now let's talk about the concept of Coulomb's law. So first of all, di ba ganiya kay nag-talk ta about charges and how objects have charges. Now, charges are like qualities or characteristics of personalities of people. It is something that we have. But while it is something that we have, it also has an effect on other people. For the case of charged particles, charges are something that they have, and the effect that those charges have on people is the force that exists between objects. So that force can either be repulsive or attractive. But the rule that they follow here is that opposites attract and alike charges repel. So say for example that this is positive and this is negative. So tendency is the charge that exists, that the force that exists between them is attractive. So blue narwhal here exerts a pulling force ni penguin, and penguin also exerts a pulling force ni narwhal. But what if we have Swan, Mr. Blue Swan? So let's just say both of them are negatives. Therefore, the force that exists between them is a repulsive force. So narwhal here has a tendency to push Swan away, and Swan has a tendency to push narwhal away. Now, we're talking about forces, right? Now this dude named Coulomb, of course you know Coulomb from a while ago, coined or created this, came up with this formula. So by scientific way of saying it, it means that the force or the electric force between two objects is directly proportional to the product of their charges, which is the Q1, Q2. And the force is also inversely proportional to the square of the distance between those two objects. So basically, an explanation of this, okay, the stronger the charge of these two, okay, the stronger the force. That is, if ang quality ani niya, ang ihang negative qualities kay mo strong from 1 coulomb to 5 coulombs, o kani siya ang ihang negative qualities kay mag from 2 coulombs to 6 coulombs. If you multiply that, kay you'd know nga greater na ang ilang force. So the more that they want to stay away from each other. But if ever their distance, let's say that their forces or their charges are constant. So ang ilahang distance, the farther they get, the weaker the force gets. Makadako ang distance, makagamay ang force. So if there's this physical distance among them, a big physical distance, then the less likely that they'll hate each other. Okay, they're already away from each other. But the sad thing is, that kind of effect also happens in attraction. Like, let's say in a failed LDR relationship, or yeah, long distance relationship, they could be attracted as much as they want. But if magkalayo gani sila niya, ang ilang charges kay mo stay the same, walay improvements, then magkalayo sila, the attractive forces kind of decreases. The force decreases. And they're not attracted to each other anymore, and they just break up. Okay, that is so sad. Well, anyway, mauying aside, the same kind of thing also happens to the law of gravitation. Now, if you look at the book, they also have the formula for gravity, wherein ang imong i-use kay dili na ang charge, not the charges anymore, but the mass. And there's also a specific kind of constant to follow. The only difference, they have the same pattern, but the only difference between the force of gravitation and the electric force is that electric force happens to be both, can either be both attractive or repulsive depending on the charges, right? But in the law of universal gravitation, I don't know if this is a law, but it's an equation, there can only be attractive force. Because gravity is like, it talks about attraction. So, no repulsion, just attraction. That's for gravity. But in electric, there's both attraction and repulsion. So, that's basically